Welcome to the workshop with TogetherCrew, brought to you by MetricsDAO. Today, we are going to be learning about a very interesting topic, which is how to analyze social interaction networks using Neo4j. So we're actually going to learn how can we use this Neo4j for network analysis. And also, we'll be doing some analysis of social interactions in online communities. Um, so today with us, we have TJ, who is from the TogetherCrew team, and really excited for the session today. And over the course of the session, there is an opportunity to ask questions. So do drop them in the chat, and we'll get back to those questions. Right. So let's kick this off. And TJ, teaches. Sorry, I'm struggling to pronounce your name. Over to you.
Thank you. Yeah, hello everyone. My name is Chitse, but I also go by Anne. So if that's easier, please call me Anne. I do a data analysis at TogetherCrew, and today we're gonna share a little bit more about data analysis on Twitter data during this workshop. I will first give a little bit of an introduction of what we do at TogetherCrew, and then we'll dive into our Twitter Neo4j database structure. I'll explain how we store our data there, how you can think about relational data, and then in the end, I'll also show an example of a query you can do on such a relational database. And then I will recap everything. So let's see, move to the next slide. There we go. So at TogetherCrew, we are providing insights for successful Web3 communities. And we recognize that DAOs and other online communities depend on the health of their community. And understanding and measuring these factors can be quite challenging. And so we started off doing research into how to measure this. And similarly to how a person's health is an aggregation of the health of many organs, which are an aggregation of the health of cells, our research shows that the health of a community is the aggregations of its nested systems. And so we look at the individuals, at the relationships between individuals, at cliques. So these are smaller subgroups of individuals that are part of the community, and also how these smaller subgroups then are related to each other within the community. And finally, also how the community is part of a larger ecosystem of other connected communities. And so in this talk, we'll mainly focus on the relationship between individuals. And we'll be doing that for Twitter data. So we distinguish between interactions, interactivity, and activity. And so not all messages count the same. Or we're very interested in whether people are talking alongside each other or whether they're actually connecting. So maybe you might recognize that from like being in a Discord server and people are just shilling their own projects or talking about like a coin that they're interested in, and then not actually having conversations. And even though these communities might seem like there's a lot of activity going on, it seems like there might be a lot of engagement. In fact, there's not much connection. It's not really a community, but more a platform where people search for an audience. And so we are studying interactions between community members, so between two community members, and out of that we can make a whole network of interactions. And we do that for different online platforms. So we do it currently for Twitter and Discord, but we also have other platforms coming soon. And when I talk about interaction, you can think for Twitter about replies, mentions, likes, retweets, quote retweets. Really an interaction that connects two different Twitter accounts. For Discord, similarly, you can also think about replies and mentions or emoji reactions. But for the scope of this talk, we'll be focusing on the Twitter interactions. And so on these different categories of interactions. And to dive deeper into that and study that, I will share how we store this data in Neo4j. So we take this data from Twitter, and then we use it in Neo4j, which is a database type. that is really useful for storing relational data. So as you can see, an interaction is a relation between two different community members. And that's why we're using Neo4j to store that information to have relational data about all the relations between different community members. And in that, we have nodes and edges. And a node, you can see that as a point in the network, and an edge is a connection between two nodes, between 2 points in the network. And so in this context, we define, as you will see soon, different types of nodes and different types of connections between those nodes. You store all the data from the Twitter interactions into the Neo4j database, so that afterwards we can directly query these connections and this network of relationships to then give us interesting outputs. And to get us familiar with the example or with the format of the database, I will use an example. So let's say we have a tweet, and the tweet is tweeted by an account. So we consider Twitter accounts as a node, and those will be indicated with green boxes. And for these Twitter accounts, we store some information like the username and the ID, when was the account created, some other things that I didn't put on this slide. And then we have a different type of node, which is the tweet itself. And so that is the blue box in this example. And for tweets, we also store some information like when was it created, the tweet ID, who was the author, what was the content, and also some other things like which hashtags were used. And then since the account tweeted the tweet, there's a relationship between the account and the tweet. And so that is indicated by the arrow between the green box and the blue box, which is a tweeted relationship. And so in this case, the account tweeted the tweet. And so therefore, there's a relation between the account and the tweet. So that is just one type of relation between a tweet and an account that exists. Another example is the like. So it could be that another account likes the tweet. And so that is shown in this example. Now the other green box is a separate Twitter account, and the Twitter account liked the tweet, and so that is indicated by the black arrow, but now with liked. So this is a different type of relation. And that is our first type of interaction. So this is the first way in which we can store an interaction in our Neo4j database. So the next interaction that we'll be looking at is the retweeted interaction. And so that is shown in the example here. So besides liking the account from the TogetherCrew, also retweeted the tweet. And so they tweeted the same tweet. And between these two tweets, there is a retweeted relation. And so the tweet on the right has a retweeted relation with the tweet on the left, as a way of visualizing another form of interacting, where now from the main account, from TogetherCrew, there's a tweeted and a retweeted connection to the tweet from the I am Zube. So that's another way of visualizing the retweet interaction. Then next, we have also the replied interaction. And so now we have yet another account, and this account also liked the first tweet. And in addition, they replied to it. And so we have also a reply node, which is a different type of node, indicated by the darker blue box. And for this reply node, we also store some information like when it was created and the ID of the tweet or the reply and the author. This is connected to the account that sent the reply and also to the tweet that the reply was sent to. And so you have two new edge types, the replied and the to, where replied indicates which account sent the reply, and to indicates to which tweet this reply was sent. And so there's yet another example of an interaction that we can store in Neo4j. Then, in addition to these interactions so far, we'll be adding another type of interaction, which is the quote retreat. And the quote retweet is really similar to the retweet, where you have an account that tweeted a tweet, and that is indicated by the connection on the top. So you have the green box connecting to the blue box with the tweeted connection. And this tweet is then connected to the tweet that we've been using as the example with a quote retweeted connection. And so there's yet another type of way in which accounts can interact with each other that we also store in our Neo4j database. And then finally, in this quote retweeted example, there's also a mention, and that is the last type of interactions that we store. And so this tweet mentions MetricsDAO, and that is shown by a edge that connects the tweet to an account with a mentioned edge. And so in this way, we can store all kinds of different interactions from Twitter into a single database that we can directly query. And that allows us to study all the different types of interactions that we're interested in. So to quickly recap what we've been talking about so far, we first showed a tweeted connection, so a connection between an account and a tweet to show that this account sent a tweet. Then we talked about a liked connection. So this is between an account and a tweet, and the account that liked the tweet. Then next, we talked about the retweeted connection. So this is between a tweet from an account that was a retweet to another tweet, and that retweet is captured within this edge, the retweeted edge. And then afterwards, we talked about replied connections. So now an account replied to indicated by a connection between the account node and the reply node. And this reply node is then connected to the tweet that the reply was sent to. Then we covered the quote retweet connection. And so this is between a tweet that quoted an original tweet, and that is indicated by the quote retweeted edge. And finally, we have the mentioned connection. And so this is between a tweet that mentions an account and the account that got mentioned. And at first sight, this might seem a little messy or overwhelming, all these different arrows and connections and lines and nodes. And so you might wonder, what is the point of this? Like, why is this helpful? Or yeah, why don't we just use our normal SQL database and don't worry about all these connections? And that is as follows, because when you have all of this relational data already included in your database, you can really easily query these connections, and you don't have to run like query information and do additional analyses on the queried information. You can just scrape your data from Twitter, store them in this format, and then immediately run analyses on that data about the relations in your query and pass that on to your front end for visualization. And so, for instance, let's say we want to compute the number of retweets and quote retweets that an account received over a certain time period. And so we are going to use this database structure to come up with a query that allows us to get this information, the number of retweets and quote retweets that an account received within a certain time period. So what we want to do is we want to count the number of retweeted and quote retweeted edges that connect tweets from the account of interest. And so all the incoming edges, I colored them here in red. And for this case, we just have one tweet as an example. But you can imagine if you look at a much larger number of tweets, there will be a lot more of these types of connections. And so we'll be filtering these connections. And we're only interested in this case in the quote retweets and the retweets. But you can imagine doing something similar for likes or for mentions or replies, depending on what kind of question you're trying to answer. And you can just update your query and yeah, get the right information. And so what a query could look like, and these queries are written in Cypher, which is the language that you can use to query Neo4j databases. is first of all, we're going to look for all the tweets out of the whole collection of tweets that have an author ID that matches with the account that we're interested in. So in this case, the account ID in caps is where you put your ID identifier that corresponds to the account that you're interested in, so that you're only looking at tweets from that account. So in this example, if we're interested in the tweets from I am Zube, we filter for that ID only, and we don't worry about other tweets that other accounts might send. So that's what you see in the first line. And then when we have selected all of those tweets, we select all the specific quote retweeted and retweeted edges that go into that tweet. And so once we first filtered for the right account, we now filter for the right edges so that we only have the quote retweet and the retweet edges, and not things like the liked edges or the mentioned or replied edges. Because for this case, we're interested in the retweets and the quote retweets. So that's what you see in the second line. Then in addition to that, we can add some additional filters. So for instance, maybe we want to exclude all of the cases where the author retweeted or quote retweeted their own tweet, because that doesn't show an actual interaction between two different accounts. It's just an account sending their own tweet again. And so we might want to exclude the account ID from all the quote retweets and the retweets. And in addition, we were interested in looking for a specific time period. So we also filter out all of the cases where the created ad date is larger than some timestamp that we identify, or some date. And so that is what you see in the third and bit of the fourth line. So what we have now is we have selected all of the tweets from the account that we're interested in. We've selected all of the interaction types that we're interested in, so the retweets and the quote retweets in this case. We then threw out all the cases where the author of the retweet or the quote retweet was the same as the author of the original tweet. And we threw out all the cases that were outside of our time period that we're interested in. And once we've applied all these filters, we can just count the number of connections, and then we got the total number of retweets and quote retweets. And so this is just one example of how you could use such a Neo4j database with relational data. And this is a very straightforward example, like for this case. But you can take this a lot further. For instance, by selecting specific nodes and specific relations, and then doing certain graph theory analyses on the subnetwork that you created by applying your filters. So you could study the amount of clustering, like are there certain Twitter accounts that are mainly interacting with each other and form a cluster within the larger network? How decentralized is this network? Is everyone quoting and retweeting the same account, or are there different groups that quote and retweet each other in a more decentralized, spread out manner? And so this is just to give a taste of how you could use this relational database, and how you could do a lot of very advanced, pretty powerful analyses directly in queries on your database. So instead of just extracting your database and then creating a separate analysis script, you can do all of these analyses directly in your query already. And that's why we are working with Neo4j, because it's a really efficient way to do analyses on our data just through querying our database. And all it requires is thinking out how to optimally store your data in that database, and all of the different connections and nodes that you identify. And so in this talk, I gave an overview of how we do that for our Twitter data, and showed an example. So to recap, DAOs depend on the health of the relations in their community. And these relations can be studied through social interaction networks. And you can do it with data that you find online. So for instance, from Twitter, like in this example, you can also think of Discord, Telegram, Discourse. There's all these kinds of online platforms with interactions, and we can take that data and store that in Neo4j, since Neo4j is a powerful database for storing relational data. And so we can store all these relationships in Neo4j database, and then use Cypher to come up with queries that directly study these relations. And so you can directly query this relational information from Neo4j and do all of your analyses in these queries instead of in separate analysis scripts. And so, yeah, if this interests you, if you want to learn more about this, always feel free to reach out either on Discord or Twitter. Always happy to talk more about data with people. And yeah, feel free to reach out. I'm looking forward to hearing from you. And if there's any questions, yeah, feel free to ask them now or at a later time if you're watching this back later. And always happy to answer.
Awesome. Thank you so much for the presentation. And I will share the links now in the YouTube chat so you can connect with Together Crew and ask any questions, and do ensure to join their Discord server to connect with their community. Um, yeah. And as mentioned, like if there are any questions, then now it's a really great time to ask. And otherwise, you can always just reach out to Together Crew afterwards. Um, yeah. And just wondering here, like what's next then for Together Crew? What can we expect to see coming up in the
Yeah.
future?
So we're like currently very interested in bringing in as many different platforms as possible, because we think that DAOs exist on multiple platforms, and different DAOs might lean on certain platforms more than others, and we want to cater to all of them. And so we have Discord implemented, we have Twitter, but we're also working on Telegram and exploring other platforms that we want to include as well. Also looking at on-chain data. And then, just like almost everyone who's excited about data analysis, we're also very excited about GPT. We're finding a lot of different use cases for GPT, both through direct prompting, but also through GPT agents. And we're turning those into features at the moment, so that yeah, people can harness the power of GPT to yeah, study the health of their DAO or their online community, as well as helping them make it more easy to exist within an online community, and yeah, make the overall output of these online communities and enhance them by letting them utilize the power of GPT. So those are our main focus points. Adding additional platforms in a similar manner as with Twitter. So we have our Neo4j database, and then we can run queries on that, and also including GPT powered applications.
Awesome, exciting developments, and yeah, and really interesting. It'll be interesting to see how ChatGPT is going to evolve their platform, and yeah, and what's coming up. Um, and I guess if there are no more questions, then we can um, finish today's session. Thank you, everyone who attended. Um, and thank you so much, uh, Teacher, for the presentation. Um, and I hope all of you have a lovely day ahead.
Yeah, thank you, and thank you for listening, everyone. I'm looking forward to hearing from you.
Awesome. Bye bye.